In this demo, we're going to look at Aembit support for Google Workload Identity Federation, also known as WIF. Before we get started, there are a few things I want to point out. So anytime you connect to Google's cloud using APIs, it's going to want you to authenticate. There are a few different ways to do the authentication, and here we see there are API keys. These are static and these are long-lived, and we'll talk about why these aren't necessarily the best, but you can also see here it says that many of the Google APIs don't accept these API keys. The next one is OAuth. OAuth is the most secure, and that's the one we're going to be using in this demo. And there are also service accounts. And when most people are using APIs, they're either thinking API keys or service accounts. But service accounts are the ones that are really the scariest. Even here you can see in Google's own notes, it says service account keys are a security risk if managed incorrectly. Okay, so we always want to use OAuth when that's available. You never want to store API keys or service account keys, things like that. There's just a lot of management overhead with those, and you really don't want to have to store them or rotate them. So now let's go and look at how we create a credential provider in the Aembit portal. One thing to point out is you see I have more than 20 credential providers configured. Some are using usernames and passwords. And in this case, for Snowflake, you can see that username and password has been deprecated, which is good for security. But it was supported along with things like API keys. The one we're really interested in is Google WIF. So here for Google WIF, you can see that there's an OIDC issuer URL. That's ours, and that's what's going to be configured on the Google side. And then there's a service account that I'm going to use to authenticate against. I'm not going to actually store the key for the service account itself, but that's what we're going to use when we're initially making contact with Google. And if I click verify, we have successfully verified that the audience and this project is tied to the service account we have configured, but there isn't any key stored, unlike some of the other credential providers here. I do have keys. If I go over to the next page, you can see a lot of the ones I have configured initially had API keys, like Open API. That uses an API key. They also have other means of authentication, but we want to make sure that we're not using static long-lived tokens, and we're taking advantage of the most secure thing available. In this case, that's Google WIF, and it's OIDC. The service I'm going to be accessing is Google's BigQuery. Under BigQuery, I have an employees database. I've uploaded just a handful of employees there just to do a quick query. In this case, it's not important what the data is. It's just the demos for how I'm going to be accessing it. I'm going to go to IAM just to point out a couple things. First, I'm logged in to GCP using my personal account, but I'm not going to authenticate using my personal account. I'm actually going to use a service account, but I'm not going to use the service account credentials directly, and we'll show you how that's done in a minute. So this is the service account that I've configured, but I'm actually going to be using Workload Identity Federation to get a dynamic short-lived token. You can see here I've created a pool, and that's how WIF works. You create a WIF pool, and under the WIF pool, I have Ash Provider. This is going to be where I get my short-lived tokens using OIDC. If we take a quick look at the flow, what you're going to see is I am connecting from a Kubernetes workload. That's going to try to access a Google Cloud resource. In this case, that resource is BigQuery. And my code is not going to have any credentials like username, password, API keys. It's not going to have any means to authenticate. It's just going to be the API call itself. But what happens is that Aembit Cloud goes out, verifies the workload identity pool, which knows that OIDC is enabled. It's going to ask for a short-lived token using the service account defined, and then the service is going to be made aware that it should accept the short-lived token when it's sent from the workload. So the workload actually makes the API call directly. Aembit injects the credentials with the secure token, and then everything magically works. Now let's look at an API call being made before we look at how it's configured. You can see here that I'm making a curl call. The curl call is to BigQuery. The Aembit WIF config is my project. The database is called employees, and I just want to get back a few rows of the data in a single table. You can see that there's no authentication. There's nothing configured that I had to put into the header like an API key. But when I hit enter, you can see that I actually pulled back rows from the database. Again, all these names are made up and the emails are made up, but the data really isn't what you should be concentrating on. It's how I made a call without needing any authentication information in the code itself. Now let's look at how this is all done. First, let's go and look at the policy. This is the policy I'm going to be using. The first thing we do is we define which client workload is going to be connected. And this client workload is in my Kubernetes pod. And we're using the Kubernetes pod prefix name. In this case, it's Globex. I'm going to minimize. It's actually Globex portal. You can see we have Globex portal. That's what we're using. I'm also connecting to Google BigQuery. So if I go look at the quick details, you can see bigquery.googleapis.com. And if we look at the actual call itself, that's exactly the URL we're using. Then the authentication comes from the credential provider, which is the one we saw earlier, which is configured for WIF. I put in the audience, which is in my project. I also put in the service account, which I had shown earlier. There's also a few more things that I have configured. First, I've configured a trust provider. So the trust provider means that we're cryptographically verifying that the client workload is who it says it is. And the way I do this is by checking my Kubernetes cluster. So the Kubernetes cluster says, I need to know exactly who you are before I do attestation. So my Kubernetes cluster is attesting that the identity of this client workload is correct. The other thing we're doing is I have a time policy. So this job can only run during working hours. So if you see here, I only have it running Monday through Friday, 8 a.m. to 5 p.m. That's the only time that this job can run. And I also want to make sure that this job is coming from California. And this configuration is pretty easy. We just basically put in the country and then the subdivision. In this case, it's by state. It checks my public IP and makes sure that that public IP address is something that's assigned to California. So I have a few other conditions in place to further restrict when this job can actually run. If I go to reporting, here is the call that we made a little bit ago. And if I dive into it a little bit more, you can see that it's identified my client. So it knows my Kubernetes system. It knows that it's also going to Google's BigQuery, and it does the attestation from my Kubernetes cluster. It passes and verifies both of the conditional checks we looked at. It retrieved my identity. It got a short-lived token from Google WIF, and then we injected into the call, and that's why the call is successful. All of the policy was validated, and everything's fine. So now let's look at GCP. Under GCP, we go to Logs Explorer. And then in Logs Explorer, you can see here that it received the call, it generated the token, and then it sent the token back to Aembit to be injected. You can see that the security token was created out of the Azure WIF pool and then sent back to Aembit, and then Aembit injected the short-lived token into the API call. In summary, once this is configured and an API call is being made, I don't have to give any of the credentials publicly. My developer never sees the credentials, so it's not going to be leaked. But all of the API calls are made successfully and securely without ever having to give away service accounts or any keys. Thank you.